Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of the OpenShift Administrator Office Hours. Today we're talking about controlling pod resource management. But the one and only Andrew Sullivan here has some follow-up from previous episodes. So why don't you start off with that there, Andrew?
Indeed. Well, thank you, Chris, and happy Wednesday.
Happy Wednesday indeed. Yeah.
It's gray. It's nasty here in Raleigh. I've got piano movers in and out of the house, so apologies
if you hear
banging
any
and
bumping
shouting.
or banging,
Just know that it's temporary, and everybody's probably fine. Probably. Unless you hear sirens. In which case, I might.
Would we hear sirens from? Yeah, I guess we would. Yeah. But I bet I got you beat in the temperature department, sir.
Yes. Well, right now the thermometer on the other side of the room says it's 77 in this room, but that is sitting on top of a computer, so it's probably getting a lot of exhaust heat. Yeah.
Yeah, it's negative 11 Celsius, 9 Fahrenheit. So yeah, it's a little chilly there.
Oof. Let's see. My computer says it's 45 here. So yes, you win.
You.
I think. I'm not sure if that's a win or a loss.
It's the race to the bottom, that's for sure.
All right. So this is. Oops. Sorry about that. If that
no
just
worries.
Banged in your ear. So this is the OpenShift Administrator Office Hour. So the goal of this next hour, or 57 minutes, as it were, is to give you all, our audience, the ability to ask us questions about anything that you want relating to OpenShift. So I have an administrator background across many different disciplines. Chris, I know you have the same as well. So we'll do our best to answer any questions that you happen to have, be they administrator related or developer related. Just know that we'll definitely have to phone a friend if it comes to the developer side of things. That being said, don't hesitate at any point in time to send us a chat. Across Twitch, across YouTube, across all the various platforms that we're on. And apologies for the dog who seems to have escaped at the moment.
Oh, fun.
So don't hesitate to ask any of those questions. Regardless of what we're talking about today, as Chris said, today we'll be talking about managing resources for applications, for pods, etc. But don't let that be the only topic that you want to bring up.
Ask whatever you want.
Exactly. Yeah, that's what we're here for. We just use the topic to fill in for when we don't have those questions.
Right.
So as Chris mentioned, as I usually do at the start of these shows, I have some follow-ups, some clarifications, a lot of times some corrections, because Andrew is often wrong. Christian, I know. So this wall, when I moved offices, this wall is a lot closer, and the picture is basically too big. It takes up too much room. So I need to find smaller pictures now. So the raccoon, which is actually hanging right over here, is a 24 by 24. And
that's kind of big. Yeah.
Yeah. This wall is 2 feet behind me. So yeah, way too big.
Just go with screens, man. It's way better. You can change stuff if you want it.
I do appreciate your attention to detail, Christian. That means a lot to me.
Mm-hmm. Yeah.
So again, ask questions at any point in time. So follow-ups, a couple of things to talk about. So first, a couple of weeks ago, maybe 3 or 4 weeks ago, right? We talked about updates, I think, and disconnected. And a couple of times now on the stream, I've showed the Cincinnati graph data.
Mm-hmm.
So Cincinnati is the update service inside of OpenShift itself. And the data that's found in that repo is effectively how OpenShift determines, or OpenShift knows, hey, I can update to this version from this version, or I can't update to this version, or that type of information. And if you look at it in the raw repository, and I'm going to share my screen because it's easier for me to talk that way. So if we look at the GitHub repo, and we just go to openshift.com and we'll search for Cincinnati. And we want the Cincinnati graph data. I'll push this into the chat here. So if we look inside of here, the raw data is not easy to interpret, right? So for example, if I go to channels here, I can look at, for example, the stable 4.6, and I have this big long list of all of the versions that I'm able to update from and to inside of here.
Yeah.
So oftentimes we have used a third-party site that is published by one of our product managers, Rob Zumsky, to kind of get an easier visualization of this. Better solution, still not great, right? It's unofficial, it's third-party, and it was still very text-driven, so it's sometimes hard to understand.
Yeah.
However, Rob very helpfully pointed out yesterday that we have a new tool from the OpenShift Labs folks.
Yay.
And I have to say, I really like this thing. This thing is phenomenal. So,
oh, where's the link to this thing? If it's
yeah,
phenomenal, I need to know about it.
I'm pushing it in here.
There you
Christian,
go.
don't ruin that Apple buying DuckDuckGo. That's not okay. So when we look at this particular tool, it's really good for a couple of reasons. So first and foremost, this gives me an upgrade path. So remember, with OpenShift, I can't go directly from, say, 4.4 to 4.6. I have to do an intermediary 4.5 first. So for example, let's say that I want to use, today I'm on stable 4.4, and maybe my cluster has 4.4. We'll go with 19. I'll just choose one of these at random.
There you go.
And I want to update to the latest version, right? 4.6.12. I know that that's not the latest. 4.16 is technically out, but I think it is. I don't think there's any update channels for it because it's like brand new, like
brand
Monday.
new. Yeah.
So essentially what I've done here is say, I want to go from 4.4.19 to 4.6.12. Show me what that looks like. And if my login didn't time out here, it generates this. You need to go from where you're at, change your subscription, or not your subscription, your channel to 4.5, update to 4.5 to 27, change your channel to stable 4.6, and then go to 4.6.12. So it walks me through step by step what I need to do. And then down here below, I have each one of the steps that I need to take in order to do that. So click administration, go to cluster settings, set the channel to stable 4.5, select version 4.5.27. So it walks me through each one of those and exactly how to do that. Super, super helpful, right? No longer any guesswork of, okay, if I go to from where I'm at 4.4 to 4.5 dot something, am I going to have to do another 4.5 dot something update to get to a version that's eligible to update to 4.6? And so it takes care of all of that. The other thing it does is it generates this, I'm not going to say not useful, but very difficult to read update channel graph.
That is something. Yeah.
So we've seen these a number of times. So this is what we generate these internally and share them sometimes. This is the visualization of all of that YAML data that I showed over here in the repo, right? So this is all of the edges connecting to all of the versions and what that looks like as a visualization. So I find this useful for a couple of reasons. But useful might be a stretch. So for one, over here in purple, or excuse me, in light blue, the highest version in the channel. So it's pretty easy to see, okay, the highest version I have available is 4.5.30. And if I kind of click and hold this, you see how it highlights all of the source edges. So I can see all the versions, right? What version do I need to be at in order to update? So that's kind of useful. You can sort of drag these and rearrange them if you really want to. It seems a little futile to me, but
I just, when it comes to graphs like this, I just can't.
Yeah,
it's just too much for me to like.
It's a lot.
I'm glad there's the highlighting and dragging around, but like I need something a little bit.
Yeah,
like, I have a wide screen. Use it, right?
So one thing to note in this view, you see, let me go back to the stable 4.5. It's actually highlighting the path that it has recommended to me. So up here at the top, remember it was 4.4.19 to 4.5.27. So here's my 4.4.19. You can see 4.5.27 is my update path. You notice that 4.5.30 is available, but I can't go from 4.4.19 to 4.5.30. So if I had just blindly chosen one of those versions, right, I would have had an error or it wouldn't have been available. And then likewise with the 4.6, it'll do the same thing, right? It'll show me the path that it has chosen for me. So from 4.5.27 to 4.6.12. So again, useful. Definitely encourage you to check it out if you're going through the update upgrade process, etc. There is this other show update graph by channel. This is basically exactly what you just saw, that massive line chart, just for all the 4.6 versions instead of just the ones that I had selected. So whether or not that's useful, up to
it's
us
there
as individuals, but it is there. It is an option.
Yeah.
The most
do with it as
answer.
you please. Yeah.
So let's see, other things that I wanted to follow up on. So one of our viewers, Killer Goalie, had reached out to me, I think it was 2 weeks ago, which was the week after we did a show on disconnected. So one of the things that we ran out of time for was mirroring an OLM catalog from connected to disconnected. So I will point out that I believed the documentation as it was written, and when unfortunately we ran out of time, so I didn't encounter it on while we were broadcasting or while we were streaming. But there's actually a bug. So the goal here is kind of twofold, right? If I want to mirror a catalog, so let me pick let me bring up my cluster here. Go to Operator Hub. So I have these provider types, which are effectively analogous to a catalog source. So let me switch over here and do an OC get catalog source -a. And you see I have these different catalog sources here. So the goal is I want to take these Red Hat operators and I want to mirror all of the operators that are in there over to my disconnected network. Let's switch back.
Very common use case. Yeah.
Yeah. So if I just select this provider type of Red Hat, like these are all of the things that'll get included. So we do this as it's two separate things that have to happen. So one is I need to mirror the index, the catalog index. And then the other one is I need to mirror basically all of those images. So the index is pretty straightforward. So again, I'm going to switch back. Apologies for all the jumping around. So if I do an OC describe catalog source Red Hat operators.
And folks, if anything isn't readable for you, let us know. We'll increase font size.
Please.
Yeah, we'll make it readable for you.
So one of the fields in here is the image, right? So all I need to do is effectively mirror that image. There is a very helpful command for that. So it is OPM commands, and we covered all of that during the previous session. So I did get this far of how to create or how to pull down that image. The step that I didn't do was, okay, I pulled down that image locally. Now I just need to use Podman to export it, right? And now I have it in a file that I can put onto a thumb drive or something like that and move to my disconnected network. So the other side is mirroring all of those images. And this is where it gets messy, because in theory, I should be able to use the command ocadm catalog mirror to mirror those images. And we even have an example here of mirroring from a file, right? Or here's from mirror from mirror to file. So at least with 4.6.12, I will admit I haven't tried it with 4.6.6 or 16, whatever version I'm on, because I just deployed that yesterday evening.
Right.
So this didn't work. Effectively, what happens is it mangles the output into the mirror file, and it causes it to be invalid. So let's see what that looks like.
Oh, now I'm curious what it looks like.
So if I were to attempt to, here's one of them. So if I were to attempt to mirror this data, and let's make that easier to read by eliminating all the noise on the screen. So I've got my OCADM catalog mirror, my source index image. So this is one that I pruned so that it only includes the OpenShift virtualization operator.
Nice.
Which, by the way, is 549 images totaling 45 gigabytes of data, because it pulls all versions and all the dependencies and across all architectures. So there's a bug that's where it requires you to do this filter by OS, so it pulls for power and all of that other stuff as well as x86.
Mm-hmm.
And then In this instance, I have, right, and I don't want to do that, right? I want to go to a file. So I'm going to say dump all this stuff to a file at just this location. And it'll think for a moment. And what we're going to see is and maybe it'll work because again, this is 4.6.16, right? It's going to dump a whole bunch of error messages into the mapping.txt file. And basically, instead of being file : / location, it's /file : / location, which is a mangling. So effectively, and the fact that it's already not failed tells me that this is already fixed in 4.6.16. So effectively, it wouldn't work. Because this is probably going to work, what I can do at this point, or once this finishes, is I would be able to tar gzip all 40 something gigabytes and move that over and then reverse this process, right? So simply change this so that the file one comes first and then my disconnected registry name is second, and then apply my image content source policy. So just know, at least for now, even if you're not using 4.6.16, if you haven't deployed 4.6.16 cluster, it looks like if you use the 4.6.16 OC client, judging by the not error that I'm getting at the moment, it may actually work for you. So Killer Goalie, if you're out there, if you're listening, please know that it's worth giving a test. That being said, I'm going to stop that now just in case it's trying to pull down a whole bunch of data.
You don't want your disk to blow up?
I pulled it down once. It's sitting in my object store. I don't need it again on the file system. But just know that I did create a BZ for this. So they are looking into it. So it may just get closed and say fixed in the new version. Maybe they'll backport it. I don't know. But just be aware of that.
Cool.
Okay. So the other two things quickly that I had to talk about are, and Chris, you know that I like to talk about things that I see come up internally that are on behalf of customers or kind of preemptively addressing customer issues and concerns.
You are a very customer focused person. Yes.
Thank you.
You're welcome.
I try. So the first one is the cluster network definition. So let me switch back over to my CLI instance. And if we go to here, and yep, that's the one I want. Notice how I have the clean one. That's the one without my pull secret.
Good call.
So inside of an install config, I have this networking stanza, and inside of there are going to be 3 network definitions. So I'm going to start at the bottom and work my way up. So service network is the set of IPs that will be used, that will be assigned to service definitions. So when you create a new service object, it will be given an IP from this range.
Nice.
So the machine network CIDR is the public, right? So the actual network inside of your environment, where at least one interface from your nodes, from your machines, will have an IP address. So this is important, and I've talked about this before. This is important for things like the SDN. That's how it authoritatively determines which interface to use. If it's missing or if it's incorrect, basically it doesn't see an interface on that subnet. It just chooses the first interface and hopes. It's good for things like proxy config. So if you're doing a cluster-wide proxy, this subnet is automatically added to the no proxy list. So we see that a lot of times with folks who they're deploying a proxy, they don't set this correctly, and the install just fails repeatedly.
Yeah.
I've got my proxy config correct. Well, you can, if you don't set this correctly, you can manually add the subnets to the no proxy, and then it should work as expected. So that's one common reason why proxy fails. And then the third one here, cluster network. This is the range of IP addresses, this /14, that will be used to assign a subnet of this size, /23 by default, to each node in the cluster for pods to utilize. So if I have 10 nodes in my cluster, each node will be assigned a /23 out of this 14. And pods that are instantiated on that node will be assigned an IP address on each one of those subnets, right? So if I switch back, just to give us an example here, I want this one. And if I go to my nodes, and I'm going to choose this worker node and look at our pods, And what I should see here is, and I'm just going to pick one of these at random. When I scroll down to find my IP address, see this one is 10.129. If I do the same thing again, so let's go to nodes and go to a different worker. And we'll choose another random pod here. See, this one is 10.128. So each one is going to be on a different subnet inside of there. So we had basically somebody asked, why are these such big ranges, right? Do I really need a /14 and a /16 for these networks? And the answer is maybe. So the host prefix of a /23 is, we do this because the maximum number of pods per node is 500. And a /23 is effectively 510 usable addresses. Right. There's 512 technically, but of course, first and last, blah, blah, blah.
Yep. Yeah.
So we need a /23 to be able to maximize the number of pods, right, or reach that maximum number of pods per node. If you have no intention of ever putting more than, say, 256, pods or 254 pods on a node, sure, bring that down to a /24. Nothing wrong with that. Do I need a /14 here? Well, that depends on how many nodes you have in the cluster and the size of the host prefix.
Yep.
So, for example, if I have 50 nodes in my cluster, and I know I'm looking over here because that's where you are, and I realize that the camera's over here. I should stop doing that.
You should look into the lens of the camera.
I know.
Yes.
So if I have 50 nodes with a /23, so 510 times 50 is 25,500. No, I did not do that in my head. I did that yesterday when I responded to the question. So I knew that one off the top of my head. So 25,000 IPs falls right in the middle of a /17. So I think a /18 is like 16,000 IPs and a /17 is 32,000 IPs.
I mean, I can pull up my subnet calculator if you want me to.
So 25,000 means that I need to have at least a /17. So you can reduce that. Same thing for the service network, right? How many services do you expect to have? How, basically determines how many IPs you would need on that particular network. So one of our illustrious essays also pointed out that he prefers to start at the bottom of this range. So rather than 10.128.0, do a favor .0 here over, say, 10.128.128.128.
Okay.
Because if you need to expand it, so maybe you need to add some more IPs, if you roll over into the next subnet, that's harder into the next, right? If you exceed the next octet's capability,
right,
that's a lot harder to do. So,
and painful, yes.
Yep. But do remember, effectively, the cluster network, the service network, they don't need to be real IP space, right? They don't need to be routable IP space.
Right. Please don't have them as routable IP spaces.
Exactly. So I know a lot of times we have IP space, I feel like, is a lot like city planning, right? Some cities, it happens very organically. I'm looking at you, Boston, and some others. Some cities, it's very planned, right? New York City, et cetera. So sometimes you end up with a big patchwork of available IP space, and finding a contiguous, 14 or 16 is hard in the non-internet facing IP space. So you don't necessarily need those.
No, you don't, but they are there.
Yeah. So the last thing I have is a question courtesy, or I guess it's a question, courtesy of Christian. So Christian and I were chatting yesterday about Vsphere. He brought up Vsphere data store clusters. So if you're not familiar with the concept of data store clusters and VMware, they're effectively the same thing as a DRS cluster. Right? I take multiple data stores, I put them into a cluster, and when I'm provisioning my virtual machines, essentially I just select the data store cluster and whatever my capacity is, and it chooses which data store to put it into. Similarly, it will automatically, if it's allowed to, storage vMotion between the different data stores to balance, right, different characteristics, performance, capacity, etc. So the question was, why don't they work with, OpenShift? Why don't they work with the storage provisioner? And the reason is less to do with OpenShift and more to do with, the storage provisioner itself. So unfortunately, the in-tree provisioner doesn't support data store clusters at all. Basically, it doesn't recognize them to be the same type of object, so you can't specify one and let it do its thing. I don't think the CSI driver works with them either, but I have not personally verified that. So if you want to still take advantage of multiple data stores, you have two options. So one, and the fully supported way, is to go in and just add more data stores into your Vsphere config. And let me post the link to that of how to add. Here we go. So I will post this link in here, and I'll also bring it up on my screen.
Nice. Thank you.
After I log in, of course.
I feel like I just logged into this.
I know, it's never ending.
Yeah. No, I did to look at your graph. Maybe that was a different browser. Whatever.
All right. So down here we have this workspace definition, right? So we can add multiple of these in order to define multiple data stores, and then we have one data store per storage class definition. Kind of clunky, right? That means that whoever's creating the PVC has to be aware of that, right? It's not always a good thing. So the storage provisioner does support the concept of policy-based choosing. And I should have thought ahead here and had this link already up and available. But I happen to have it bookmarked, which I was told that bookmarks are an antiquated concept.
Really?
So yeah, you just remember all the links, right? You just.
Well, I mean, I have taken a different approach to bookmarks, right? Like I'm tired of them being like locked in a browser, so I've put them in a different app, but they're still bookmarks, right? Like
yeah. Well, same here.
Yeah.
Anyway, so in here we have the ability to specify a policy, right? So I can define those policies as being tag based.
Mm-hmm.
So I could select each one of my data stores here. I can add a tag, right? We'll call this storage. Yep. I'm not really going to worry too much about it. So I can assign tags to each one of my data stores, and then I can come up here and go to policies and profiles. I can create a VM storage policy, and then I can use one of these in my storage definition. So I can say storage provisioner, choose a data store that meets this policy essentially. So maybe that's, flash storage, maybe that's, I don't know, block storage, whatever that happens to be.
Right.
And that can match multiple data stores. So I can kind of mimic that same functionality of having more than one data store masked behind one interface. So the problem is, well, it's not a real data store cluster. So I'm not getting any intelligent placement based off of the normal storage cluster rules.
Mm-hmm.
It also won't move those disks according to storage DRS policies. Not that we encourage that to begin with.
Right.
And last, it will choose one data store. So the policy will execute. It'll say data store 3, you're the first one to come up. And it will create PVCs in that data store until it's full. And then it will choose another data store, and it will create PVCs in that data store until it's full. So it kind of sequentially fills each data store rather than doing them on an individual or spreading them across all of the data stores in there. So data store clusters, they sort of work, but they don't really work. Effectively, we definitely don't recommend it. It doesn't give you the benefits that you would expect. So unfortunately, I don't have a good answer for that today. If data store clusters are your preferred way of choosing storage for virtual machines.
If somebody wanted to do that, who would they reach out to first, you think? Us or VMware?
So the in-tree provisioner is supported by Red Hat.
Okay.
However, the in-tree provisioner is deprecated. Right? Remember, in-tree provisioners are being removed in the future. I don't remember what version it is now.
Mm-hmm.
So essentially, sure, we can create an RFE. Maybe something like that is already there. But if I'm being honest, I wouldn't expect action to be taken on it. So the CSI provisioner is, and the cloud native, what VMware calls cloud native storage, right, is the active and current and the recommended way of consuming that storage. So CSI provisioners are maintained by the storage provider. So you would open an RFE with VMware in that instance. And then VMware does support, right? So the VMware CSI provisioner is supported by VMware with OpenShift. And you can absolutely deploy that in there. Just follow their deployment guidance. So usually the big change for us on the OpenShift side is making sure that the virtual machine hardware version, which is very an oxymoron, right? Virtual hardware version,
Right. Yeah.
is at least version 15. And then you can deploy the CSI provisioner in there. You can take advantage of the vCenter integration. You can take advantage of, if you're using version 7, vSAN version 7 with vSphere 7, the RWX volumes from vSAN, all that other type of stuff. Okay, I think that covered all the things that I wanted to bring up here beforehand. I'm looking through my tabs. They all look good. So, or they all look like I've addressed them. So I think we're okay.
Yeah, we're good.
All right. Any questions?
No, Ricky said that city planning is a great analogy. So yeah, that's a good one. Yeah.
Thank you. I actually came up with that right off the top of my head, and
wow,
it seemed apt. So, all right. So today's subject is controlling resource consumption. And, we've talked about sizing before. We've talked about, a bunch of different aspects of what's happening inside of the cluster. But at the end of the day, right, we can size the clusters as much as we want. But if the if the application teams aren't responsible stewards of those resources, there's not a lot we can do. So we can help control that through a couple of different mechanisms at the Kubernetes level.
Mm-hmm.
So the first thing I want to point out is there is a very real and very distinct difference between the amount of resources that have been requested and the amount of resources that are in use.
Correct.
And this plays a huge role in sizing. So for example, I can create a pod that does nothing except sleep, right? Not consuming 0 CPU time,
mm-hmm.
right? 0 memory. But I can associate a request with that for as much CPU as you'll let me, right? As much memory as you'll let me. And from a scheduling perspective, Kubernetes will effectively reserve those resources.
Mm-hmm.
So I could have, these massive nodes in my cluster that have effectively no real work happening, but from a scheduling perspective, they're full. So we want to be very conscious of, we want to be very aware of what those requests, what those limits, what those configurations are, because it can affect that pretty significantly, right? This cluster is running in Azure, right? I could effectively auto scale up to dozens or hundreds of nodes that are doing effectively nothing, costing me a lot of money, and I'm not doing any work. So really important to be aware of that. The other thing that I'll soapbox a little bit on is trust the metrics tools. So I'm doing a webinar with a partner of ours, Turbonomic, tomorrow. They fantastic tools and they're one of many of our partners that do this.
Mm-hmm.
For looking at and seeing and evaluating the real resource utilization associated with an application, so that you can then go to that application team and be like, look, I have proof that you're not using all of these resources that you requested. Let me downsize. I promise it's not going to affect your application, but it allows us to be more efficient and better at what we do and more cost effectively. So trust the tools, build the trust with the application team as an administrator that, hey, we're not taking these resources away because, you're never going to get them back, but when you do need them, they will be there. Right. So again, that whole trust thing that keeps coming up again and again. Okay.
Yeah.
So the first thing I want to talk about is kind of a couple of core things. And I've already talked about them in previous episodes, so I'm not going to spend a lot of time. And I just mentioned the first one, which is a request. So each pod can define a requested amount of CPU and RAM,
mm-hmm.
right? It can also define a couple of other things inside of there. And this is not the page that I wanted, so I'm just going to ignore that page. So that request is effectively a please guarantee me or please schedule me on a node that has at least this much resource available.
Right.
Now, the opposite of that is a limit. So a limit is don't allow this pod to consume any more than this amount of resources. And the two of those don't have to be equal.
No.
Right. And they both don't have to be defined either. So the
But
combination,
it is advisable to define
yes,
them. Yeah.
Very much so. So the combination of those two things determines the QoS class associated with our pod. So if my resource request, if my request is smaller than my limit, it falls into the burstable class, right? I think it's burstable.
Wait, say that again. If it's under or over.
So let's see. If a request is less than the limit, then it is a burstable QoS class.
Okay.
Right?
Yeah.
If there is no request or limit specified, it is a best effort class. And if the request and the limit are the same, and I had to check my notes on here just to be sure, it is a guaranteed QoS class.
Nice.
So what do these mean? So the biggest impact that these have is when it comes to resource contention. Effectively, so we can think of guaranteed as being the highest, we can think of best effort as being the lowest. Effectively, it will start at the bottom, best efforts, and it will begin evicting those pods from the node as resource contention occurs. And
you have nothing specified, it's gone.
Exactly. Right. So if you want to, and there are some constraints on that, right? It's not going to, this is why you want to have a pod disruption budget. Right. So that way it doesn't go in and eject all 40 pods associated with, this application component and suddenly everything's down, right? Pod disruption budget prevents things like that from happening. So you can see that there's a number of factors that play in here, right? That all go into this grand scheme or this grand plan of how do I manage not just the resources, but also my application. It's really important for application team and administration team, infrastructure team to work together to ensure that we all understand those things. I know from when I was administrator, I may or may not have done this before of, hey, I need to put this node into maintenance mode and reboot it, right? And accidentally taking something down or something, this can't be vMotioned. It's fine. I'll just turn it off for a minute. And, we want to avoid those types of scenarios. So working together. All right. So requests, limits, right? Request is, for lack of a better term, a reservation. It's not really a reservation, but that's how I'm going to describe it for right now. Limit being don't consume any more than this, right? Those two combined lead to the QoS policy. So how do I prevent Chris and Chris's project from consuming all of my resources?
And me, I'm gonna get it all. I'm a resource hog. Just say it.
Exactly. So I hope you are not surprised by the page that you've been staring at for the last 5 minutes or so. The answer is a quota. So I can place a quota onto a namespace, onto a project that says, and it defines different aspects of resources that you are allowed to consume or not consume. So you can see here, I can define a limit for CPU as well as memory. I can define requests for CPU and memory. So remember, you are not allowed to consume more than X amount of CPU. You're not allowed to reserve more than X amount of CPU. And this is just the legacy, same as requests, right? Interestingly, as we scroll down further in this page, this also applies to storage. So I can define on a per storage class basis the amount of the capacity, so the number of gigabytes that a particular project can consume, as well as the number of volumes that a particular project can consume. So you're not allowed to consume more than 100 gigabytes of bronze storage in more than 8 persistent volume claims. Right.
Okay. Yeah, that's what I wanted to get to, right? Like, where is the class of storage and so forth? It's That's where it is.
And then you'll note that up here, I skipped over these two at the top. So these two apply across all storage classes, all storage types. So maybe I've got, gold, silver, bronze, cardboard, plastic storage classes. And individually, you are allowed 100 gigabytes from each one of those 5. But I can say up here at the request.storage level, total, collectively, you are not allowed to consume more than 250 gigabytes across those 5. So maybe that's your full 100 gigabyte allotment of gold, your full 100 gigabyte of allotment of silver, and then 15 gigabytes each of, bronze, cardboard, and those, right?
Yes.
So storage resources, just as important. Now, note that this is gigabytes. It's capacity based. Effectively, Kubernetes has no concept of things like latency or IOPS, which is, of course, important for many storage operations. So just be aware of that, right? That it is a thing. And there are ways that you can control that depending on your storage vendor. So refer to their provisioners, their CSI provisioners, because many of them have a lot of different things to help with that. I know Pure, I know NetApp, I know Dell all have the ability to define things like QoS policies and IOPS limits inside of their storage class definitions. So
cool stuff.
The last one that I'll touch on is ephemeral storage. So when we talked about sizing node storage, right? Remember we talked about how /var is where things like an empty dir gets created at. And it is a finite amount of capacity. So using these ephemeral storage definitions, I can control how much of that local host storage, basically the ephemeral storage underneath of our live containers, the project is able to consume. So this one is a little harder to nail down because you can say, oh, Chris, you get 1 terabyte of ephemeral storage. Don't use any more than that. But maybe your hosts, right? And by default, we recommend 120 gigabytes drives on those OpenShift nodes. Well, that would effectively be like 10 nodes worth of capacity that you could extinguish. So it's a little bit harder depending on what your configuration is, but may still be an effective, at least, control mechanism. So, okay. So we've talked about what the objects are, right? So requests, limits, QoS classes. We've talked about how to implement quotas, etc. So quotas are all great and all of that. Now, but maybe I don't want you, much like we defined up here, you're allowed to consume, this much of bronze, but this much overall.
Right.
So can we do the same thing with CPU and memory? The answer to that is yes, using a limit range.
Okay.
And unfortunately, there's not a good definition of a limit range in here. Let me copy.
No, that would just make sense.
I'm going to copy one from over here and go here. And oops. I'm just going to borrow the YAML editor inside of here.
Yeah, why not?
So we have a limit range definition where we can say effectively a couple of different things. So one, if you are, I'm not going to say lazy, I'm not going to say irresponsible, I'm going to say careless application administrator who does not define any of these values yourself, right? We have defaults that can be defined in here, right? If you don't create a CPU memory, right, ephemeral storage request or limit, you're going to get what's defined inside of here. And note that these can be defined at the container level, as well as at the pod level, as well as at the project level.
Nice.
Additionally, you can specify the min and max available. So your quota is 100 CPUs and a terabyte of RAM, but you cannot create an individual pod that consumes more than 2 CPUs and 2 gigabytes of RAM. Right. So kind of maybe potentially preventing you from shooting yourself in the foot. Similarly, the minimum is great. The minimum and the defaults, right, are great for that whole scheduling thing of I always want to make sure that at least some resources are accounted for at the scheduler level, so that way it can make more intelligent decisions. So limit ranges, super important, right? They help with all of these things. They help prevent people from shooting themselves in the foot. And unfortunately, I think we're going to run out of time. I'm going to share a GitHub repo because Chris, I don't think you had joined our team yet. I actually created a whole demo on this. I'll share the video. I'll share the examples that I have from back in like the OpenShift 4.2 days. So it might need a little bit of updating, but I'll share that GitHub repo. Actually, I'll do that right now.
Okay, thank you.
And I will dig up the video as well, because that one's easy to find, I think.
You hope. So just to be clear, this demo is 2 years old and it's still viable, right?
Yeah.
Like, the resource management has not changed in Kubernetes significantly.
Exactly.
Yeah.
I don't see, at a glance here, I don't see the video. So I'll dig that up. I'll include it in the blog post that goes out with the show notes. So
wonderful.
Please keep
Yes,
an eye
thank
on.
you. Yeah. And if you're not aware, Andrew does a very good job of getting a blog post up after each episode that he's on. So yeah, subscribe to the blog and you'll see all the notes that you need to see from this show.
Yep. In the last few weeks, those have been going out at 6 a.m. Friday morning, 6 a.m. Eastern time Friday morning. So if you're an early riser, first thing Friday morning,
I mean,
drink your coffee and hear me. I'm so sorry.
I always publish my post at like 3 a.m. So, whatever.
Yeah. So I'll dig up that video. I'll share that. You also have that GitHub repo, which has a lot of examples inside of there. To your point, Chris, these are core Kubernetes concepts. This isn't OpenShift. This is Kubernetes, but it's something that I have found we as administrators really don't understand well, because a lot of times we think of it as it's an application thing, right? The devs are creating these things and assigning them with the pods without realizing or understanding how much of an impact that has on what we're doing. And that leads me to the last part of this that I want to talk about, which is, this is great. Hey, quotas, phenomenal. Hey, limit ranges, great. That's phenomenal. But each one is scoped at the project level, at the namespace level, which means that for every project, every namespace I create, I have to have a limit range and a quota. So if you're allowing users to create their own projects without, the old school way would be, hey, submit us a request and somebody will create your project and hand it over to you, right? Mm-hmm. Nowadays, we often hand over an entire cluster to them and say, go forth and do.
Yes.
Don't let me get in your way. So
it's not uncommon at all. No.
We have the ability to define a default that gets created with every project. So how do we do that? Mm-hmm. And now I need to find one of my other windows.
All the windows.
I have far too many of them.
Yeah.
So how do we do that? And we'll switch over here and clear out the noise here, because what I want to do is show this command. So OC ADM create bootstrap project template with an output format of YAML. And you can see I've simply directed that into a file on the file system here. If I look at this file, if I look at this YAML output, what I'm looking at is the template that defines how to create a project. And you can see a number of different things inside of here. Apologies, I'm going to jump up and move this window so I can see both.
Kick my desk really hard so my camera shakes. So yeah, enjoy.
Well, so I can see both my code and the chat and this all simultaneously, or pseudo simultaneously. So you can see in here we have a couple of variables, so things like description, display name. These are defined at the bottom. So we see down here the parameters. But we importantly have multiple objects inside of here. So when I create a new project, it's going to, of course, create a new project using, so when I say OC new -project, it's going to use this information to create the project object. It's going to create a role binding object that follows these types of, that has these security permissions defined. So we see the cluster role here and the user role that are bound to the admin user, whoever's creating it. We have our parameters down here at the bottom. So if I want to, for example, create a default quota, I simply add it into here. Right? So I just copy and pasted. Very simple resource quota definition here. Mm-hmm. right? So kind is resource quota, project name dash quota, right? You're allowed to have no more than 10 pods. You're not allowed to have more than 4 CPUs, 8 gigabytes of RAM, right? So on and so forth.
Yeah.
So I'm going to remove this one real quick. And then I also want to add a default limit range, which is going to be the exact same limit range that we just looked at a moment ago.
Okay.
Right. So project name dash limits is going to be the name of the object. Right. So I'm just adding in whatever it is that I want to be created. If I want to create default users, more than just the admin user, quotas, right, on and on and on, all of these things inside of here. I can define these with the project template. So we'll save that particular file. And now I want to create that object. So if I look at the head here, you can see that it is a template with the name project request. So I'm going to submit this. So I'll do an OC create-f project template. And I want to put this into the OpenShift config project.
Cool.
So if I do OC get template dash namespace OpenShift config. Apologies, I can't type and talk without saying what I'm typing. And if I try to
that's actually kind of good.
Well, if I try and type something that I'm not saying, then I end up typing what I am saying.
What you do say, no, it's fine to audibilize your commands because some people can't read it or can't, whatever.
So here's the object that we just created. So now we need to tell Kubernetes, we need to tell OpenShift to use this template when we create new projects. And we do that by defining it in the API server. So this command here, so OC get config map named config and the API server namespace. And then we're just using JSON to select one portion of that. And it spits out a bunch of different things that are inside of here, right? That it's going to use, that it's going to do with that particular API request. So effectively, we want to add another option to this, which says use this one, right? When creating that new template. So we will create our object. And I'm going to switch back to our YAML editor to show this one because I'm going to pipe it in line. So all I'm doing here is creating a new project. So you see no namespace associated with it. So you requested a new project. And then the template to use here is project request.
Cool.
So pretty straightforward. So I want to do OC apply -f and I'll paste that in there and do my EOF. So if you're not familiar with this, this is just the here doc.
Yep.
So here doc cat to it sees the NOF string and then OC apply -f with the standard input. And now we should create our object inside of here. Right. And last but not least, now we can review our same command as before. And what we should see here is now we have this API server config, project config definition. So here's our you requested a new project with our project request template. So at this point, what I should be able to do is do an OC new dash project. So we'll call this the admin office hour, AOH. And we have a new project. And I should be able to do a get. I don't remember if I needed to do something else to trigger that. Now I'm questioning myself because I didn't see the, hey, you created a new app, blah, 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 using templates.
Yeah.
Yeah, why didn't that work?
It didn't work. Okay. 5-minute warning, by the way.
Thank you.
No problem. Christian asked a really hard question in chat, but y'all can talk about it in the work channel. So yeah.
Kubernetes at its core is a resource scheduler, and it's built from the ground up to effectively and efficiently schedule workloads and resources. Isn't that an argument for setting latency sensitivity to high in VMware? Yes. So I talked about this during the sizing. So at the end of the sizing stream of overcommitment is something that we, especially as virtualization administrators, we love.
Yeah.
We overcommit the crap out of everything all the time, and network administrators love it even more. Right? It's not unusual to find, especially in a hierarchical, network architecture, to see overcommitment ratios of like 20 and 30 to 1 on those edge switches. So overcommitment is fine, but you want to do it as close to the application as possible. So that means, in the case of OpenShift, in the case of Kubernetes, at the Kubernetes layer.
Right.
The reason for that is because, let's say that I'm overcommitting at the hypervisor level. So VMware, Rev, OpenStack, whatever, is doing the overcommitment. And the hypervisor is out of a resource, right? It's out of memory. It's swapping. The hypervisor is hurting.
Yeah.
It's impacting the virtual machines, OpenShift in this case. So OpenShift doesn't know this. All it knows is every alarm that it's got is saying performance is bad. Something's wrong with the application. I need to auto scale. Yep. And it's trying to throw more pods at the problem. It's trying to scale up more nodes.
Ending problem.
And all it's doing is exacerbating that out of resource condition at the hypervisor layer.
Jesus.
So you want to basically protect the resource utilization, or the resource availability rather, at the hypervisor layer for Kubernetes. So this is a bit counterintuitive for us virtualization administrators, because normally when Chris, the OpenShift administrator, comes to me and says, "Hey, I need 10 VMs with 32 CPUs and a terabyte of RAM," and I laugh at him and say no. So the reason why this is okay is because we have things like machine sets and the ability to dynamically scale the cluster. So everybody in the stack, from the application team to the OpenShift team to the infrastructure hypervisor team, has to trust all of the tools in the stack, right? Of, hey, when I start to run out of capacity at the application layer, it's going to auto scale up. And when the OpenShift layer starts to run out of capacity, it's going to auto scale up. And we basically just have to trust that each one of those layers is going to give us the resources that we need and not give us a bunch of crap or deny those resource requests and then impact everybody above. So it's definitely a learning experience, right? I for anybody who remembers, I was at NetApp before. I used to give a whole talk 5 years ago on this exact same topic, and it's still a thing.
Still a thing. Yeah.
So
awesome.
I know we're basically out of time.
So Christian mentioned the API server is restarting. So if you try your get limit range thing again, you see not using a project.
Template, I'll figure out what's going on there. I'll include that in the show notes and figure out
cool.
if there was something I missed. So thank you to Eric Jacobs, by the way, who he created a lot of these commands a while ago. So he helped me greatly with how all of this works, although he probably doesn't know it because I plagiarized. So I'll follow up with that, make sure that we get that covered inside of those show notes. I'll also follow up with it next week just to make sure that we, for anybody who doesn't see the blog post, that's included. But
sounds good.
So yeah, thank you everybody who has been watching. We really appreciate your time. I know it's sometimes not easy to devote an hour with us, but it does mean a lot. If you have any questions, anything that we didn't address today, and I'll go back and I'll review all of the chat to make sure that we catch all of those in one form or another. If you didn't have time, or if you didn't feel like it fit, or just didn't want to ask in public, please feel free to reach out to me. I'm on social media. You can reach me, Twitter, Practical Andrew. I'm on LinkedIn and all of that other nonsense as well. You can also send me an email, quite simply, andrew.sullivan@redhat.com. Happy to take those questions. Love to get those questions. And if you don't want me to talk about anything publicly, right, I don't usually like to mention names or anything unless you're okay with it. So happy to also do that. But yeah, don't hesitate to reach out at any time. And with that, I think we're basically at the top of the hour, Chris.
Yep, time to go. I will catch you all later. Thank you for joining, and stay tuned for a OpenShift Commons briefing coming up in just a second. Thanks, everybody.